Sharia. How computer vision has enhanced security surveillance. Presented by Kamor Sharia. Computer vision has greatly enhanced security surveillance in several ways. Here are some examples. Object detection, facial recognition, crowd analysis, license plate recognition, intrusion detection. Object detection. Computer vision algorithms can detect and track objects in real time, enabling security cameras to identify potential threats, such as individuals or vehicles that are moving in restricted areas. Object detection is a computer vision technique that involves identifying and localizing objects within an image or video. The goal of object detection is to detect and locate all objects of interest within an image or video and provide information about their position, size, and shape. Object detection can be divided into two main stages. Object localization, identifying the presence of an object and its location in the image. Object classification, assigning a label to each detected object. There are several methods for object detection, including classical computer vision techniques like Haar cascades and Hog, histogram of oriented gradients. Deep learning-based methods like single-shot detection, SSD, you only look once, YOLO, and faster RCNN. Object detection is widely used in a variety of applications, including self-driving cars, surveillance systems, and medical imaging. Facial recognition. Computer vision can be used to match faces against watch lists or databases of known individuals, helping security personnel to identify and track suspects or persons of interest. Facial recognition in computer vision is a technology that uses machine learning algorithms to detect and identify human faces within an image or video stream. It involves analyzing and comparing various facial features such as the distance between the eyes, the shape of the nose and mouth, and the overall structure of the face. Facial recognition technology typically involves several steps, including face detection, feature extraction, and face matching or recognition. In face detection, the system identifies the presence of a face within an image or video. In feature extraction, the system analyzes the facial features and generates a unique set of identifiers. Finally, in face matching or recognition, the system compares the extracted features against a database of known faces to identify the individual. Facial recognition technology has numerous applications, including security and surveillance systems, access control, and biometric authentication. For instance, it can be used to automatically identify and track individuals in a crowd, allowing law enforcement agencies to quickly locate and apprehend suspects. Crowd analysis. Computer vision algorithms can analyze crowd behavior and detect abnormal or suspicious activity, such as someone leaving a package unattended or a person moving against the flow of traffic. Crowd analysis in computer vision is a field that involves analyzing and understanding the behavior and dynamics of crowds of people using computer vision techniques. This can include detecting and tracking individuals within a crowd, estimating crowd density, and identifying patterns of movement and interaction. There are several techniques used for crowd analysis, including object detection and tracking, motion analysis, and machine learning algorithms. Object detection and tracking techniques can be used to identify and track individuals within a crowd, while motion analysis can be used to estimate crowd density and movement patterns. Machine learning algorithms can be used to analyze the data and identify patterns and anomalies within the crowd. Crowd analysis has a wide range of applications, including public safety and security, crowd management in events and public spaces, and urban planning. For instance, it can be used to detect and track suspicious behavior in crowded applications, including public safety and security, crowd management in events and public spaces, and urban planning. For instance, it can be used to detect and track suspicious behavior in crowded areas, or to estimate the number of people attending a particular event for planning and resource allocation purposes. License plate recognition. Computer vision can also be used to automatically recognize license plates and compare them against databases of known vehicles, helping to identify stolen or suspicious vehicles. License plate recognition, LPR, is a task in computer vision that involves detecting and recognizing license plates in images or video streams. The typical workflow of an LPR system involves several stages, including image acquisition, license plate detection, character segmentation, character recognition, and post-processing. Here is a brief description of each stage. Image acquisition. Images or video frames are captured using cameras mounted on vehicles or at fixed locations. License plate detection. In this stage, the system locates the license plate region in the image. This can be done using various techniques such as template matching, edge detection, or machine learning-based approaches. Character segmentation. Once the license plate region is identified, the individual characters on the plate are segmented and isolated for recognition. This is typically done using techniques such as thresholding, connected component analysis, or deep learning-based approaches. Character recognition. In this stage, the individual characters are recognized and converted into text. This can be done using techniques such as template matching, optical character recognition, OCR, or deep learning-based approaches. Post-processing. Finally, the recognized text is processed to remove any noise or errors, and the license plate number is outputted. LPR systems are commonly used in applications such as automated toll collection, parking management, traffic enforcement, and vehicle tracking. Intrusion detection. Computer vision algorithms can be trained to recognize patterns of behavior or movement that are indicative of intrusions, such as someone climbing over a fence or breaking a window. Intrusion detection in computer vision is the process of detecting and alerting when unauthorized persons or objects enter a restricted area. The typical workflow of an intrusion detection system involves several stages, including image acquisition, object detection, object tracking, and alarm triggering. Here is a brief description of each stage. Image acquisition. Images or video frames are captured using cameras mounted on the perimeter or at strategic locations within the restricted area. Object detection. In this stage, the system detects and identifies the objects present in the scene. This can be done using various techniques such as background subtraction, foreground segmentation, or deep learning-based approaches. Object tracking. Once the objects are detected, the system tracks their movements over time to determine if they are entering or leaving the restricted area. This can be done using techniques such as optical flow, Kalman filtering, or deep learning-based approaches. Alarm triggering. Finally, if the system detects that an object has crossed the perimeter or entered the restricted area, it triggers an alarm to alert security personnel or authorities. The alarm can be in the form of an audible or visual warning, or it can be transmitted to a remote monitoring station. Intrusion detection systems, IDs, can be used in various applications, such as security surveillance, perimeter protection, and access control. Conclusion. These are just a few examples of how computer vision has enhanced security surveillance. By leveraging the power of machine learning and artificial intelligence, security cameras and other surveillance systems can now be much more effective at detecting and preventing potential threats, ultimately making our communities safer. Thank you for watching and listening. If